We learn about the least common denominator, an extremely important concept, similar to the concept of the greatest common factor. We will learn how to find the least common denominator for a group of fractions, and we will use that to write equivalent rational expressions. Now, if you add or subtract rational expressions, the process often requires finding the least common denominator. The least common denominator is the simplest expression that is divisible by all of the denominators in all of the expressions. For instance, if you want to add these two rational numbers, rational expressions, you need to find the least common denominator, a number that divides both 9 and 12, and a smallest such number. And that will help us, for instance, to write 2 over 9 plus 5 over 12 equals, we can multiply, before we do that, we can make sure we have the same denominator in both. If you multiply the first one by 4 over 4, remember, multiplying by 1 doesn't change this. 4 over 4 is 1. Plus, you have 5 over 12. Again, we multiply that by 1, different kind of 1. Again, this number is still the same. But now what we have is, remember we learned how to multiply rational expressions. So 4 times 2 is 8, 4 times 9 is 36, plus 3 times 5 is 15, and 3 times 12 is 36. So now we have the same denominator. Okay, so we simply add the numerators, which is in this case 23 over 36. You cannot add fractions unless you have the same denominator. That's why we need to find the least common denominator. Okay, how do we do that? Factor each denominator into prime factors. So let's apply this to these two denominators. You have 9 and 12. Factor each denominator into prime factors. 9 is 3 times 3, and that's it. 12 is 3 times 4. 4 is 2 times 2. So now these are factored into prime factors. List each different denominator factor the greatest number of times it appears in any of the denominators, this or this. Alright, so start with the first one. In the first one, 3 appears twice, so you have 3 squared. And the second one, 2. We don't consider 3 because 3 appears twice here, more than here. 2 appears twice, so this is 2 squared. If you multiply these out, you get 36, the least common denominator. And this is step 3. Multiply the denominator factors from step 2 to find the least common denominator. Okay. The least common denominators of this and this. Remember, this will help us add them or subtract them. For 10, you have 2 times 5. 25 is factored into 5 times 25. 2 appears most over here, and it appears once, so we list it once. 5 appears most here, and it appears twice, so we list it twice. 2 times 5 squared is 50. 50 is the least common denominator of these two denominators. Now let's consider these two denominators. 8 is 2 times 2 times 2, factored completely, and you have m to the power 4. We can think of m to the power 4 as m times m times m times m. 12 is factored into 3 times 4, so 3 times 2 times 2, and m to the power 6 is m times itself 6 times. So m to the power 6, this factor appears most in the second denominator, and 2 appears most in the first denominator, 2 to the power 3, so 2 to the power 3. 3 appears only in the second denominator, and it appears once. Okay, and m to the power 6 appears most in the second denominator, and it's m to the power 6. Multiply them out, and you get the least common denominator of these two denominators. Okay, this denominator and this denominator. 16 is 2 times 2 times 2, 4 times. M to the power 3, and you have n. For this one, you have 9 is 3 times 3, and you have m to the power 5. Now, looking over here, you have 2. 2 doesn't appear in the second one. It appears only in the first one. It appears 4 times, so 2 to the power 4. M to the power 3 appears in both. It appears more often in the second one. It has a higher degree, so it's m to the power 5. N appears only in the first one, doesn't appear in the second one, and it appears only once, so you have n. Then in the second one, 3 appears only in the second one, and it's 3 to the power 2, so we include that. And m appears in both, but it appears more often in the second one. It has a higher power. We already included that. So multiply these out, and you get the least common denominators for these two fractions. Finding least common denominators. These are our denominators, so let's factor them out. The first one has x as a common factor, so this is written as x into x minus 4. The second one, okay, remember the second one, this trick we learned before, this is x squared minus 4 squared. So this is a squared minus b squared. It's a minus b, a plus b. So this is written again as x plus 4, x minus 4. Alright, now we look. X appears only here to the power 1, so we include x. X minus 4 appears here and here, only to the power 1, so we include it. X plus 4 appears here, so to the power 1, so we include it. This is the least common denominator of these two denominators. Now for this, the second one can be written as, if you multiply by minus 1 both, okay, so you have 1 over 1 minus x, multiply both numerator and denominator by minus 1. So you're not changing anything. Okay, you multiply up and down by minus 1. So this becomes minus 1 over, bring in this minus, and you get x minus 1. So what we called before opposites. So this is minus 1 over x minus 1. So basically they have the same denominator, and this is their least common denominator. It can be used as the least common denominator. So this is like already ready to be used. Remember, now here you're having a common denominator. You have the same denominator. Now, writing equivalent rational expressions. Factor both denominators. Decide what factors the denominator must be multiplied by in order to equal the specified denominator. Multiply the rational expression by that factor divided by itself, that is, multiply by 1. So this is what I did here the first time we talked about least common denominators and how we can use them to add rational expressions. Okay, what I did here we decided that the least common denominator is 36, so we want to change this into 36 and this into 36. Actually should be worded this and this, both of them should become 36 because we want to have a common denominator in these two rational expressions. We do it for both of them, but we do it separately, because to get 36 from this, you need to multiply by 4. But to make sure you are not changing the number you started with, you multiply by 4 over 4. And this will give us this expression. Now, to turn 12 into 36, you multiply it by 3. So it's a different number. But again, the same trick applies. You cannot just multiply the denominator by 3. You have to multiply both numerator and denominator by 3, so that you, in reality, you would be multiplying by 1, and hence you are not changing the expression you started with. So this will give us 36. Now both of these expressions, okay, this is equivalent to this and this is equivalent to this, but now both of them have the same denominator and it's easy to add them. Okay, we'll be doing exactly the same thing over here for numbers and for expressions. All right. Write each rational expression with the indicated denominator. I want to turn this into an expression whose denominator is 36. Now, what do I need to multiply 4 by to get 36? I need to multiply 4 by 9. But if I multiply 4 by 9, I have to multiply 3 also by the same number. So I would be actually multiplying by 1. So 3 times 9 is 27. 4 times 9 is 36. Now I have a rational expression that is the same as this, equivalent to that, but it has the denominator 36. Of course, I would be probably using this for some other purpose. Okay, we're here just learning and practicing how to get the desired denominator. Like I showed you earlier, we could use that to add the rational expression to another rational expression. All right, now this. I want the denominator to be 30k. What do I multiply 5 by to get 30k? To get 30, I need to multiply 5 by 6. So 5 has to be multiplied by 6. And to get k, I simply multiply by k. So actually, I am multiplying 5 by 6k. Okay, multiplying 5 by 6k. To do that in a mathematically correct way, you have also to multiply the numerator by 6k. So you're multiplying the whole thing by 6k over 6k. 6 times 7 is 42. K times k is k squared. 5 times 6k is 30k. Write each rational expression with the indicated denominator. Okay, now this has to be written as an expression where the denominator is this. Now, what do I multiply this by to get this? The 2a must be multiplied by 3. Same with the 5, it must be multiplied by 3. So I have to multiply the whole thing by 3, which means I have to multiply up and down by 3. So multiplying numerators, you get 27. Multiplying denominators, you get the desired denominator. Okay, this one. I want this one to become this. Now, exactly what is this? If you take k common, this is k into k plus 2. So I already have this. Okay, this is already this. All I need to do is to multiply by k minus 1. But then I have to do the same thing over here. Okay, so this factors out to this, which is the same as this. I still need k minus 1. So I multiply up and down by k minus 1. And notice that this is the same as this. So you're multiplying by 1. This is simply 1, but it is a special kind of 1. Multiplying these, you get this, and multiplying these, you get this. Now this is an equivalent rational expression, but it has the desired denominator.